Hey there, my name is Maxwell Kawada, and I'll be walking you through how to repair a broken FireWire port on the FPGAs in the DaVinci Research Kit. So here you can see I have an open DaVinci Research Kit, which is a V2 model. Now I've taken the top off here by unscrewing the screws from this front port here, as well as all these ones along the side. And today I will be trying to repair this. Now this is FPGA 2 of, in our case, the MTM-L. I'll first walk you through how to notice which ports are broken specifically. Now, as a prerequisite, you're going to need one of these Unibrain FireWire cords that is connected to whatever PC you're using. We're going to use this to plug it in to the ports of the FPGA to identify which one's broken and which one's working. Now, as you can see here, I've already unplugged the FireWire ports and the Ethernet port off of this FPGA. Normally, they'll be connected as such, with this black wire connecting to the input port, this red one then connecting to FPGA 1 to FPGA 2, and then this black wire normally collects outwards to the out port. Now, what I'm first going to do is I'm going to make sure that the device is powered off. Then I'm going to take this cord that's already connected to our PC and I'm going to plug it in carefully, make sure you have the direction of it correct, because there is only one correct direction you could put it in. And I'm going to carefully plug it in to one of the ports. In this case, I'll plug it in to the port that connects to the IEEE 1394 out port. Next, I'm going to go to any terminal that is connected to this FireWire port down here. It's this gray cable. And what I'm going to do is I'm going to type ls/dev/firewire, and I'm going to press the star. Now, this is the command that'll check all the FireWire devices that are connected to the computer. As you can see here, there's only one connected, and that's the internal FireWire PCI card that is connected to the actual computer. Now when I power it on, we should expect to see a second device show up. We're going to go back to here. Make sure everything is plugged in. For example, this needs to be plugged in correctly. Then I'm going to make sure that none of these wires are touching anything they really shouldn't be. And then I'm going to power on the system. We should see these lights turn on, and then eventually this green light over here will start flashing, and then once it'll start changing colors, it's initialized. Now I'm going to go back and I'm going to rerun the command I just had. Now we can see here that a second device didn't show up, indicating that this port here, which is connected to the out port, is likely broken. Now we're going to restart by powering down and then checking the other port. Okay, I've powered down the system and then I plugged this FireWire cable, which is again connected to our computer, into the other port that connects this FPGA 2 to FPGA 1. Now I'm going to power it back on, wait for it to initialized, and now we're going to run the command again, and if it's working, we should see a FireWire device. So we can see that FireWire 1 is available, meaning that that FireWire port is working. So on this one, we have one working port, which is this one, and one broken port. So what do we do now to fix that? First, I'm going to power down the system. I'm going to unplug this cable. And then we see here that we have these two screws on the side. We're going to remove those screws as well as unplug every connection to the FPGA. This is so that we can take it off and inspect the FPGA for problems. One more note as I start removing this, as these screws can strip, so make sure that when you're removing them, you apply a pretty good downwards force so that you're not stripping these screws. Now that I've removed the screws, I'm going to grab the FPGA on these sides and I'm going to wiggle back and forth until it comes loose from its connection. There we go. And now it is off. Now, the biggest indication of a FireWire port being broken is going to be some burn marks that may be present around these diodes. However, the most common problem for this port is that either these diodes are broken or this IC is not working. Now, in my experience, it's mostly the IC that's not working, although sometimes just replacing the diodes may fix it. But in my case, just because I know that this port isn't working, and it may be a result of these diodes not working, the best thing that we can do, the safest thing we can do, is remove these 4 diodes here and the IC, replacing them with new parts. So now that I've carefully got the FPGA in my hand, I'm going to put it in an ESD bag. That'll make sure that it isn't shocked by anything surrounding by it. For example, I'm wearing this coat which may have some static electricity on it, and you have to be very careful when handling with these FPGAs, as even shock from my coat could damage the board. So we're going to put it inside of here. I've already gone ahead and bought the required items we need to replace that IC and those diodes. It's here on this form. This is going to be the part that you'll need to replace the FireWire IC, and this bottom one is going to be the parts you need to replace those diodes. So you can go ahead and save these numbers, look them up on DigiKey, and just purchase them for yourself. For performing maintenance on the FPGA, I use these tools. You don't need these exact ones, but this is what I used. Firstly, I used a Hakko FR810B airgun, as well as these 2 tips. The fine tip is for desoldering diodes, and the IC tip is for both desoldering and resoldering the FireWire IC. The solder I used was this, and it was selected for its smaller 0.4mm size. For soldering tasks, any solder wick and tweezers work. For performing soldering, I used the Weller WX2N, and this was handy because I could have 2 soldering irons at once, one with a thicker head and one with a thin head. When desoldering items with the airgun, I use this 3M aluminum tape to prevent nearby components from getting direct gusts of hot air. And for cleaning up the flux, I used 91% isopropyl alcohol as well as these cotton swabs. Lastly, for drying up some of the leftover isopropyl alcohol and for some other wiping tasks, I also use these Kimtech wipes. For viewing the small components on the FPGA, I use this high-yield digital microscope. So some key notes before I get into the soldering. Make sure that you use a lot of flux. Flux is going to be your best friend in this process, and it helps for both desoldering and soldering. First, position the FireWire FPGA underneath the digital microscope. If you have something to clamp the FPGA or keep it in place, you can use that. Here, you can inspect the diodes of interest on the board. You can find each of them on the opposite side of the FireWire ports, with each diode having 3 pins. Every FireWire port has 4 associated diodes. To begin removing these diodes, we will apply a good amount of flux on the diode's pins, and then apply hot air at the lowest air setting possible around 700 degrees Fahrenheit or around 370 degrees Celsius. We will be using low airflow to avoid other components from being removed and blown away. As a tip, while you are trying to remove the diodes, you may want to lightly touch the diodes with a pair of tweezers to see if they are loose, and then gently lift the diodes off the pads once the solder melts. Do not try to force the diodes off, as you may remove the pads they are soldered to as well. Once the diodes have been removed, you will see the pads with solder left on them, as well as some flux residue. We want to remove this solder so we can add new diodes onto the pads. To do so, we will apply more flux to these unpopulated pads, take some copper solder wick and position it on the pads, and then apply a soldering iron to the solder wick, which will then remove the solder from the pads. You should then be left with some clean diode pads. Optionally, you can clean them with some isopropyl alcohol. Next, take some thin solder, and on the side where there was only one pad, apply the solder with a soldering iron. Next, remove a diode from its packaging and place it on the FPGA board near its pad that we just soldered. Make sure you are incredibly careful while moving the diode, as dropping them or squeezing them too hard with tweezers may cause the diode to fly away, never to be seen again. Now, using a soldering iron, melt the single dot of solder and use a pair of tweezers to gently push the top pin of the diode into the melted solder. Then, remove the soldering iron to allow the solder to solidify, holding the diode in place so then we could solder the other pins. Once again, use the soldering iron to heat up each pin of the diode and the pad, and then gently push the solder into the diode pins to completely solder the diode onto the FPGA. You can then repeat this process for the rest of the diodes. After soldering all of the new diodes, you should go back and apply flux to all of the pins and then tap each pin with a soldering iron to ensure that you do not have any cold joints. You should then be left with 4 new diodes for the FireWire port. Next, to clean the board, take some cotton swabs and dip them into some isopropyl alcohol, and then gently wipe the areas we just soldered. Next, to remove the leftover isopropyl alcohol, take a Kimtech wipe and gently dab the wet areas. This will then conclude the replacement of the FireWire diodes. Now moving on to replacing the FireWire IC, we will need to apply lots of heat onto the board in this process. So to prevent any heat from damaging or removing parts around the IC, we will need our aluminum tape. First, cut a few strips of the aluminum tape and firmly place them over the surrounding components. Next, apply a liberal amount of flux to the IC, especially on the pins and beneath the IC if possible. This will make it easier to melt the solder on the pins and the large pad on the bottom of the IC. Ideally, for a hot air gun, you should use an IC-shaped nozzle to optimally disperse the heat onto the board and the pins of the IC. Set the temperature anywhere from 700 to 750 degrees Fahrenheit and hold the hot air gun above the IC, using tweezers to check if the IC is becoming loose. Once again, do not try to tug the IC off, as it should be lifted with almost no resistance after all the solder is melted. Also, this process might take multiple minutes, so be patient as to not damage the board. After the IC has been removed, you will be left with some leftover solder covering the pins and the heat pad. To remove the solder, once again, apply some flux, get some copper solder wick, and apply the heat to suck up the leftover solder. Next, you will be left with some relatively cleaner pads. Then, apply a very small amount of solder back onto the center pad, enough so that a thin layer covers the entire surface of that pad. I would recommend using a large and flat soldering iron head to avoid having too large of a spike or bubble from forming once you remove the iron from the pad. After that, apply more flux to the central pad. Now, carefully remove a new IC from its packaging and align the IC on the FPGA such that the pin 1 indicator is in the same corner as a circle which appears on the silk screen of the board. Now, carefully apply hot air directly over the IC and use tweezers to align the pins evenly onto the pin pads. Once the solder melts under the IC, it should shift into place, and then you can use the tweezers to adjust the position of the IC so that it aligns with the pads. Once you have completed alignment, you can turn off the hot air and then let the solder solidify. Next, check the pins under the digital microscope to ensure that they are all placed correctly. Now, we will be applying more solder to every pin to ensure they are soldered completely using a method called drag soldering. I will not be teaching you how to do this method in this video, so I recommend looking up some tutorials on how to do so or finding someone who does know this method. First, apply flux to the pins of the IC, and using a larger soldering iron, apply solder to the tip of the soldering iron. Apply this wet solder to a row of pins and then drag the soldering iron across the pins. If there are any clumps of solder connecting multiple pins together, apply flux to the area and use solder wick to remove the excess solder. After drag soldering every side of the IC, once again, apply more flux to all of the pins and use a smaller soldering iron tip to tap every pin, ensuring that there are no cold joints. This is an absolutely crucial step, as sometimes my repaired FPGAs would not work as they had a cold joint after drag soldering. Finally, clean the excess flux off of the board by dipping cotton swabs in IPA and gently wiping the flux off. Once again, use a Kimtech wipe to remove any areas with excess IPA on the board. As an optional step, you can also use compressed air or dust remover to ensure that there are no excess liquids underneath the IC. Finally, to double check that our soldering was successful, we should inspect the pins once again, taking a pick and placing it between each pin, gently wiggling each pin to ensure that everything is safely connected to the pad. After this check, you should be left with a completely repaired FireWire FPGA board, with a new FireWire IC and its associated diodes. Make sure you carefully check every pin and connection to make sure the board does not become damaged again. Now that we've successfully resoldered both the diodes and the IC, we're going to carefully grab it from the edges here, and we're going to put it back on its platform. Line it up, and then, do the same thing. It's just you can kind of carefully wiggle it in till it's nice and solid and down. And then we're going to plug this back in with the blue wire on the left. I'm going to plug in this FireWire cable into the working side just to make sure that we didn't break anything that we weren't supposed to. And power on. You can see the lights turned on. We're going to wait for it to initialize from this light down here. And it's been initialized. So we're going to run the FireWire command, and we see that controller is working. Alright, now we're going to power down. I'm going to move this to the next port, and if all goes well and we've resoldered things correctly, we should see another FireWire device popping up. It's now initialized. I'm going to check again, and we see, boom, we've successfully repaired the broken FPGA. So now both FireWire ports are working. We can now close up this and return it back to its original state. So I went ahead and put everything back to its original state, including rescrewing in these screws here. Also, if you changed the actual board ID on this dial, make sure you change it back to its original state. And then I plugged in the FireWire cable just connected to the computer into the in port. And because we repaired everything, we should see two FireWire devices show up when we run this command. And when we do see FireWire 1 and FireWire 2, indicating that both ports now work. Now, just one more note. Sometimes when you power on the boards over there, and the FireWire cable is connected to the computer while you do that, checking for the ports, you may not see them both. So what you have to do is unplug the FireWire cable from your computer and plug it back in, and then you should be able to see them again.